a multi-rotor system. So this is a multi-rotor system with 4 rotors. So 4 rotors means 4 masses, and we have to balance this multi-rotor system. Okay, so just like you did your what you say exercises in your theory class, we are going to do similar kind of work in our practical session. Just start. Before I do that, we download one more document. All right, can you see the picture?
Yes, sir.
Okay, so there are these 4 masses A, B, C, and D. Values of these masses are given in this table. Okay, so it is 175, 216, 236, and 197. Down there. Here. So there are 4 masses. Two, three, four. 175. 175, 216, 236, and 197. One six, 236, and 197. Okay, so these are the 4 masses. Okay. Now these 4 masses are mounted on this rotor. Let's call this as A, B, C, and D. And so these 4 masses are mounted on this rotor. In the sequence A, B, C, D, C, and so now when you see these masses in the video, you will find that a cross section of this mass is something like this, and this is where the shaft goes. So if you see the cross section of all 4 masses, cross section area is same. All right. So since the cross section area is same, centroid of all 4 masses is also same. Got it? So the location of CG, let's call it as R, it will be same for all the 4. Now when you calculate the centrifugal force, when you do balancing, how do you calculate? Can somebody tell me? Hello.
M into R, sir.
M into R, right? So that is what we generate. So is M into R centrifugal force?
Divide by omega square.
Equation for huh? What is the equation for centrifugal force? Yes, anybody?
Omega square.
M omega square R, right? So now what we do, we divide this value by omega square, and when you divide this by omega square, what remains is M into R, right? So what we get is a value which is proportional to the centrifugal force, and since omega is constant for the rotor, to simplify our calculations, we divide it by omega square. Now in our case, the radius of rotation for the CG is also same. Okay, so can I do it like this? Centrifugal force divided by omega square R. Is that okay? Will that be okay? Yes or no? Hello.
So it would be just the mass.
Yes. So what I get here, this column will be 175, 216, 236, and 197. So what does this integrate? Your centrifugal force is now proportional. To the mass. Okay. Correct. So generally, what we do, we construct the force polygon, right? We know the forces. Okay. So next step is to construct the force polygon. So after this, what I want you to do is construct the force polygon. Now, while constructing the force polygon, we are going to fix the angular position of B and C. Okay, so B is going to be horizontal and C is going to be at 90 degrees to. Now we don't know the angular position of A and D. So to find angular position of A and D, what we do, we are going to construct the force polygon. So FB will be 216. Is FB, and FC will be perpendicular to that, and that is 236. Now using these 2 points, cut an arc for FD proportional to this 197, and also cut an arc from the starting proportional to FA, that is this 170. So this will be 197, that is FD, and this will be 175. It is FA. So using this, you can get the angular position of A, B, C, and D. So this will be D. Draw a vector parallel to this FD. This will be your mass D, and draw a vector parallel to FA. So this will be your A. So these are so from this we get the angular position of all the 4 masses. So I want you to do this first step. So construct the force polygon and tell me the angular position of mass D and A.
So
Yes.
So we will have to upload this in the write-up.
I mean, I will give you this. This is not like a very finished version. So I will give this. What you say? presentation to you. I will upload it in the assignment, and using this you can you have to write the finished report. So how to write that report, that I will tell you at the end. Okay.
Okay.
So you have to add this, but all these calculations and stuff you have to add, but you have to add this in a systematic manner. Okay. So for now, I want you to calculate theta d and theta a. Tell me what is theta a and theta d. Once we find out theta a and theta d, we will go for the couple polygon. So we are going to take A as reference plane. Distance
So theta d is 199.
190,
9.
199.
So theta d 199.
Theta d is 190. And theta a,
260.
hey, you are doing it using the what is it, SolidWorks.
Yes, sir.
So if you are doing it in SolidWorks, you attach the SolidWorks what is it, screenshot.
Okay. It's okay if I
And
don't
also,
want on the
if
paper.
you are using, see, you can solve this in SolidWorks or AutoCAD, or if you don't have that, you can do it manually also. But whatever method you use, you attach that work only. Don't copy somebody else's work and do that. I will give 0 marks for that. All right. So let's just let me.
So you said you're uploading some new write-up or something. What was that about?
I'm not uploading new write-up. What I'm going to do is I'm going to upload this current PowerPoint presentation which I am sharing with you, and it is going just you have to use that and create a finished work. I have already uploaded the write-up. I will tell you how to. Don't worry about the write-up right now. Just concentrate on the experiment.
Okay, sir.
Are you following what we are doing? If you have any questions, please ask. If you are not following, please ask. Okay. Everybody is getting similar answer. Anybody with a different answer? So what is the angle made by mass d with horizontal? Can you tell me? This blue arrow which I marked. Can you tell me what is that value? Hello.
19, sir.
19D. Okay. Similarly, can you tell me what is the angle made by A with the horizontal?
80.
80 80 degrees. Okay. Now you have the angular position, okay, and you have the couples. So I have defined A as the reference plane, and these values B I don't know, C also I don't know, Y is X is Y. Now because of the limitations of the instrument, I have to fix the value of distance of mass D from A as 180. So that is the maximum distance that I can accommodate on that apparatus. Is 180. So now I can calculate the couples. So these couples I have calculated in this column. So this is a CB. So CB is 216X and CC is 236Y. And what is CD? Just calculate and tell me. That is 180 into 180 into 197. Tell me the value. Are you calculating? If you are not following, please ask immediately. 180 into 197. So that is equal to 3546. Okay. Now choose a suitable scale, and now we are going to construct the couple polygon. Now CD is along this angular direction. So construct a vector CD along this arrow. And I don't know value of CB and CC, but I know they are mutually perpendicular. So CC is in vertical direction and CB is in horizontal direction. So wherever they intersect, this is your CB and this is your C. So find out the value of CC and CB and tell me the values, and then tell me the values of X and Y. So this is your 11th experiment. All of you are following what we are doing, B division students.
Yes, sir.
Sir,
Yes,
so Y is 48.44.
Y is 48.44. Okay, and X is
155.4.
okay. X is how much?
So wait, 155.4.
Sure. Okay. Sorry. X is 155. 155.4.
4.
Huh?
155.4.
Everybody is getting this value. Please cross check. Hello. Anybody else calculating?
Sir, I'm getting the opposite values such as
Correct.
x.
It's opposite. The other batch also got it opposite.
Yes, sir, I've got x is equal to 47.2 and y as
Correct.
150.5.
X is 47.
0.2 and y is 150.5.
47.2 and Y is
Sir,
150.5.
1 160.
150.5.
150.5.
sir,
Yes.
CB
This
is
is
bigger than CC. So X will be bigger than Y.
what?
Sir, CB is bigger than CC. So X will be bigger than Y.
CB is bigger than CC. How do you know that?
So from the diagram,
No.
property
This is an
diagram.
approximation.
No, sir, even I'm getting the same diagram.
But the other batch also got these values which are comparable to this one. So please recheck your calculations. See, X is 46.516 and Y is 43.99. Just double check which values you are getting. I think these values are correct. Can somebody cross verify? Do it. See, you can do it mathematically also. CD is how much? 335,460. So sine 19 is equal to 11544. So that is CC 11544. Are you getting this value as CC?
Yes, sir. So if we divide this by 236, we are getting 44.
So CC divided by 36. Yes, correct. CC.
Yes, sir,
Yes,
then X is
Y.
bigger than Y.
Correct. You are correct. See, CD is how much? This is this value 35460. Alright, and this angle is 19 degrees. Alright, so CC will be sine of this angle, CB will be cosine of this angle. That is 35460 cos 90. Okay, so this will be 33528. Right? So it will be 33528. So x will be 11544 divided by 216. 236. 236. One 11544 divided by. So this is y and this is x. This is 48.91. So y is 48.91 and x is 8 divided by 16. That is 155. 5.2. 5.2. All right. So what does this indicate? The position of B and C are interchanged. Okay. So the correct sequence will be A, then C, then B, and D. All right. So this is the correct sequence. Okay. And BAC is how much? 48 approximately, and this is 155 approximately, and this is 180. Am I correct?
Yes, sir.
So now you have the angular position of the four masses. This is B, this is C, and this one makes an angle of, this is D, this makes an angle of 19 degrees with the horizontal, and A makes an angle of how much? This is how much? 80 degrees, correct?
80. Yes, sir.
60 minus 180, that is 80 degrees. So now you have the lateral position of four masses, and also you have the angular position of four masses in balance condition. So in this position, the system is completely balanced. Okay. So now we are going to verify this experimentally by setting the what do you say, the masses in this angular position and this lateral position. Right? So that part is done in the videos. So go to your the class materials folder in the documents folder. The files folder, go inside general. In that you will find that lab number 11 balancing, and in this there are 5 videos. Okay, so this is the complete remaining part of the experiment is done in this video. Okay, so go through this video in the sequence. So A division students can start. B division students, I will download the videos and upload it. हो हो जस्ट एक मिनिट पुढे पुढे बसता याच्यावर तिकडे तिकडे जाऊया ना. Hello, anybody from B division who is attending the practical?
Yes, sir.
Prince Prince Badan. Hello. Okay, so what I will do, I will just temporarily add you in the group, and then you can download the videos and share it with BDV. Is that okay?
Yes, sir.
Okay, so I will just add you in the group. Okay, I have added you in the group. Just check whether you are able to access the class materials folder.
Yes, sir. 1 minute.
So go to that lab number 11 and download these 5 videos from 1 to 5 and see it in that sequence only and share it with the B division students. Continue with that, and once you are done with the done with seeing those videos, let me know. Then I will tell you about the I will tell you about how to write the report. All right. Any questions? Hello. Any questions? A division, B division.
No, sir.
Okay. All right. So continue with that. Just see the 5 videos and then let me know.
Yes, sir. I have downloaded the video.
Okay. Share it with B division students and watch the videos and let me know. Hello. Prince, you are sharing with all the students, no? B division.
Yes, sir.
Yes, sir. Done with the videos. Hello, sir.
Yes.
Sir, done with the videos.
Okay. Just a minute. Okay, so let's discuss the write-up, how to prepare the report of the PDF file. Okay, so now can you see the PDF? The same thing is uploaded in your team, that is A1, A2 team. So in this, the objective it should not be static. Alright, just edit out this part. So what you have to do, you have to take a printout of this, edit out this part with the whitener. That static part, for some reason that remain. So objective is to study dynamic balancing of the system. Aim is as it is. Introduction is fine. Theory is also fine. Then this table is also fine. We have modified it. Then the description is also fine. Then experimental procedure. Now the experimental procedure, you have to write the procedure as what we have done in this experiment. Alright, got it? Okay, so whatever steps we have done, we have that you have to enlist. Okay, so then complete the observation table. Here also modify this table, mass, moment, couple, write the appropriate in that on the top right, that centrifugal force divided by omega square r. Okay, like that it should be. So I will attach that PowerPoint for your reference. Okay, this also will be same. So rest of the stuff will be same. Diagram you can attach the printout. So in this way you have to prepare the your report, and in that addition to that you have to attach this force polygon, couple polygon, and whatever calculations you have done as I have shown in the PowerPoint, that should be also be there. Thank you. I will
So it's
attach.
okay to upload the SolidWorks
Huh?
screen. Can I upload a SolidWorks screenshot?
Yes, you can do it in SolidWorks, but don't share it with other students.
Yes, sir.
If I see the same thing is getting repeated, then I will reduce marks.
So is it fine if we make the observation table manually along with the drawing and upload it?
Observation table is already there, na?
So, but we can't edit it now, so.
But you have to just fill that values in there. That you see, anyways, you have to take a printout of this write-up. This part you are telling, na? So you don't
Yes.
have to edit it. You have to just take a printout of this write-up and fill this out with hand
So,
and scan it and upload it.
sir, can you increase the deadline by a bit?
Yeah, deadline is flexible. By next week you can complete it.
So the deadline is set for today, actually.
That I will extend.
Okay, sir.
Or any other question?
No, sir.
Let me just also quickly update the PDF. I updated the. I'm updating it. That small correction was there. The writer. So make sure you take the latest version. So I updated the write-up.
So we have to write the procedure too.
Pardon?
So we have to write the procedure in our own words.
Yes. Procedure you writing.
Okay.
Whatever procedure we have followed, that you write.
The procedure for the experimental setup was the balancing diagram.
No, how you perform the experiment.
Okay.
Perform the experiment. how we found out the angular position and the lateral positions of the masses. Then how did we verify that experimentally?
So in this, the radius of rotation is set to unity, right, for all?
It is not unity. We are dividing that centrifugal force by omega square r. It is not unity.
Acha, okay, sir.
Instead of dividing it by omega square, we are dividing it by omega. एग्जाम 1 बजे तक रहेगा शायद 1-1:30 बजे Alright, I have also uploaded the PowerPoint. Also share that on the chat. I also shared that on the chat for the B division students. All those things should be included in the new write-up.
Sir,
Yes.
sir, is it okay if we print only the pages on which we have to write?
Yeah, you can arrange it any way you want. That is okay.
Okay, sir. Thank you.
But then I have to then delete that page, cancel. If you are able to arrange that, fine. Yeah, you can do that.
Okay, sir. Okay. Sir, and also about the term test 2, what will be the syllabus? Can you tell us?
Term test 2,
Yes,
the
sir.
entire syllabus, remaining syllabus,
Yes,
will
sir.
be
Can
there.
you repeat?
Whatever has been the remaining 4 modules. 4 modules have not, sorry, 3 modules have not been taken in the first test. So the remaining 3 modules. So tomorrow we will be starting with the multi-degree of freedom system. I have already uploaded the notes for that on your drive on the Teams. So tomorrow
Sir,
we will be starting with Rayleigh's and Dunker is for the transverse loading of the shaft for multi-degree of freedom system. So even that portion will be included.
Sir, in term test, will we have the diagram, balancing diagram graphically?
Yes, yes, most likely. Yes.
So it will be of how many marks? 10 marks? Any idea? Like, or
That
it
we
takes
have not
time to
decided.
solve?
So it will not be a very big problem. The question will be proportionate.
Okay.
Sir, for term test 1, we had first chapter and the third chapter. Na? So for 2, second, fourth, and fifth will be there. Na?
2, 4, and 5, correct.
Okay, sir. Thank you.
Any other question? Stepping out for a minute.
No, sir. Thank you.
I will just come back in a minute.
Okay, sir.
In case I am not available, come back and answer it.
Hello, sir. Sir. Hello, sir.
Okay, guys, we can stop for today.
Thank you, sir.
Any questions you can ask?